And we are down to the last rule of differentiation, the chain rule. Now, having said that, there are some other rules which apply to specific functions like exponential rules, trig rules, and so on. But the functions we've seen so far can be applied to any rule. So when do we apply the chain rule? Well, first of all, it's important to realize that we apply the chain rule to composite functions. Notice that we use the product rule for product functions, the quotient rule for quotient functions, the addition rule for addition function, but we apply the chain rule not to chain function, which there aren't any, but to composite functions. So where does the name come from? Well, it comes from the way the rule works. And you may remember this, I hope you remember this one as well, but I also hope that you're going to refine the way in which you understand it and you use it. So if we have a function that is the form f of g of x, so f composed with g of x, the derivative is obtained by computing the derivative of the outside function, keeping the inside, the g of x, as if it were just one variable, and then multiplying that by the derivative of the inside. So the name chain rule comes from the fact that the method, the rule tells us to make a chain of derivatives going from the outside to the inside of the function. Now we're gonna, again, this time in class, I'm gonna show you a little way of practical way, a little mnemonic to remember how the chain rule works, but I need some objects to do that, so I'm not gonna do it on the video. But let me show you, I'll not really give you a proof, but a little bit of an idea based on Leibniz notation. Remember, what we're trying to do is we're trying to take the derivative of something that looks like f of g of x with respect to x. Well, what we're going to do is we're going to make a little substitution. We're going to take that inside piece, that g of x, and we're going to call it u. Then what that means is that we're trying to compute the derivative of f of u with respect to x. That doesn't work very well because f is a function of u, but we're trying to take the derivative with respect to x. Now what we're going to do is something we've done before in algebra very often. Namely, we're going to multiply and divide by the same thing, namely du. Now we're cheating a bit here because remember that fraction is really not a real fraction, but it's the limit of a fraction. And therefore we have to be careful that the limit does not create a mess. But in fact, it turns out it doesn't. So everything works fine even if this is not a proper fraction. Now, having done that, what I'm going to do is I'm going to switch the two denominators. So I'm going to write this as dfu over du times du by dx. And now you can see where the chain rule comes from. Because, of course, the first product in this expression is simply the derivative of the outside function, keeping the inside fixed, as if it were one big variable. And then the second one is just the derivative of that inside. Remember, u was the inside, was g of x, with respect to the regular function, a regular variable x. Okay, so again, a little bit of practice will allow you to use the the chain rule effectively. But before you jump into practice, which you definitely want to do it very soon, let me give you one more bit of advice. Differentiation rules that I've shown you were applied in single situations, but in general, when we're dealing with a generic function, we may have to apply several rules by combining them in an appropriate order, and we're going to see in class how that works. And so in order to do that, it may be a good idea to use what I call the get ready first principle. And this is a principle that does not apply only to derivatives but to anything that we do in mathematics. And that goes as follows. Before performing any mathematical computation or solving a mathematical problem, what you want to do is consider rearranging the given information, the givens, right, so as to make your task easier. So for instance, what this means is that once you're given a function, you may want to change the way that function looks so that which rule we need to apply first and which one second and so on will become much more apparent. So keep this in mind again when we do derivatives. We're going to use it again when we'll do integrals, and keep that in mind as a general rule of mathematics, as a general little trick that you want to use anytime you're doing anything in mathematics, applied problems, word problems, and so on. So this is all in terms of differentiation rules, but I want to start giving you a little glimpse into differentiation methods. So hang on for the last short video.